Hello, everyone, and welcome to session two of out of 8 sessions that I'll be doing. Hopefully, you watched the first one. If not, I will show it to you at the end of this video. So, for session two, for 2-1, we will be going over factors. So let's get started. What are they? So, factors are the numbers that go evenly divisible go evenly into the given number. So basically, pretend I have the number 32, and then we know that 2 goes evenly into 32 because when you divide them, you get a whole number, which is 16. So when I say evenly, I don't mean that it has to be even. I just mean that the outcome is a whole number. So how can you find them? You can find factors by having pairs of two numbers that equal the given number. So we know that, let's use the same example, 32, the pair that goes with 2 would be 16 and 2. So 16 and 2 would both be factors of 32. So now let's do some practice based on this. Find two factors of the number 24. You can pause the video and do this, and then you can also do number 2. What are all the factors of 28? Okay, hopefully you pause the video. If not, let's find this out. So it's very simple. This trick, two factors. If you get this on a test, just put 24 and 1 because any number times 1, as we learned in the identity property of multiplication, equals the same number. So these would both be factors. Now number 2 is a bit tricky. You just have to go in sequence from 1, 2, 3, and then you keep going until you can't find any more. That's why I did a small number, or else it's very hard and it's not really useful. So yeah. So for 28, let's start off with 28 and 1. Then let's go to 2. Is 2 divisible by 28? Yes, it is. When you do the division, you hopefully got 14. Now, is there any more? Let's try 3. Okay, when you get that, you'll know that, oh, 3 is not divisible by it, so it can't be 3. Now let's go to 4. Yes, 4 works because 4 and 7. And then you reach 8. 8 doesn't work. Then you reach 9. 9 doesn't work. Then you reach 10. 10 doesn't work. 11, 12, 13, and then once you reach back to 14, you know that these are all your factors. So you should have gotten 1, 2, 28, 1, 2, 14, 4, and 7. Now, on to 2-2. Greatest common factor, GCF. Important note, greatest common factor must have more than one number. Because if you were to find more than one number, because if you were to find the greatest common factor of just one number, it would just be whatever number you're using. So that's why there's really no point in using one number. So that's why on a test, if you ever get this what the greatest common factor is, it'll either be 2 or more numbers. So there's two methods. First is the list method, where you just list all the factors of both numbers. So we can use 28 and 24. So 28 let's do 28. We already know that these are all the factors. And remember, when it says greatest, you have to find the greatest. So now let's go to 24. Space it out. Okay, 24. We already know 24, 1. Now let's see, does 2 work? Yes, 2 works, and you know that it is with 12. Then let's see next one. Okay, so 3. Does 3 work? Yes, it also works. 3, and then you have 8. Does 4 work? Yes, even 4 works. 4, and then 6. And after you do all this, you'll know that 6 is the last number. Now we test out the greatest. So the greatest in both for this one is 28, and then this one is 24. So it doesn't work. So after you go through all of them, you will figure out that 1, 2, and 4 is common in both, but 4 is the greatest one. So you know that your answer for this one, the greatest common factor of 28 and 24, is 4. Now the cake or ladder method. This is a much more effective one, and I will be going to here to do it because I cannot do it on docs. So we have, this is how you would do it. So some people call it ladder, some people call it cake. I think it looks like an upside down cake when it's done. So 28 goes here, and then 24 goes here. So first you think of any one number besides 1 that goes into both of them. The first one that comes to my head is 2 because 2 goes into any even number. So you would put 2. Now you would do this and put the next two numbers that when you divide it by 2. So 28 divided by 2 is 14. And then 24 divided by 2 is 12. Now we can use the same concept that we used for this. And since these are both even, 2 will also go into these. And now we have 7 and 6. And we no longer can do any more numbers. So that means that this is our endpoint. So now to find the greatest common factor, you multiply the numbers that are on the left side. So that would be 2 and 4. 2 and 2, sorry. So 2 times 2, you get 4 as our answer for the greatest common factor. Okay, let's go back. So we would get 4 also. Now let's do some practice. So you can pause the video, do all 3 of these, and when you're done, you can unpause the video and I'll go through the answers. Okay, so hopefully you paused it. If not, do it now, or if you got confused, I'll tell you the answers by working through. So use the list method to find the GCF of 12 and 26. So let's list it. So for 12, we start, obviously, with 12 and 1. Next, we go to 2, and we know that 2 goes in with 6. Now we go to 3. 3 goes in with, and 4, so 4. Now we go to 4, but we realize that 4 is already here, meaning we can stop. Now, let's go to 26. Let's go start with 26 and 1. Then we can go to 2. Yes, 2 works. 2 and 13. And then I'm not going to do the rest, but after you go through every single one of them, you will figure out that 26 is not divisible by any more numbers. So now you can look. You see that they only have 1 and 2 in common, and 2 is the greatest one. So our answer is 2. Now, number 2. Use the cake method to find the GCF of 24 and 124. You're gonna need a paper for this. You can't do it on docs unless you guys are geniuses and you found a way, or you can just open a PDF like I did. So yeah, I'm gonna do it here. So the numbers were 24 and 124. So 24 and 124. So this one we can start with 2, and we get that 12. And I'm gonna have to do the math for this. So the way you divide, if you don't already know, you do this. Then 12 divided by 2, because 1 is less, is 6. And then 2 divided by 4, 4 divided by 2 is 2. So now we can move on to the next step. So you get 62. We can do 2 once again. I just keep on to use 2. I keep on using 2 until you can't use 2 and you stop, or you have 3 or some other number. So 2, you get 6 and For this one, I also have to do the math. If you can do it in your head, then you are very smart. But I think I can do it in my head. So let's just do this again. So 6 divided by 2 is 3, and then 2 divided by 2 is 1. So this would be 31. Now we can see here that we no longer can do anything else. And so we stop here. Even though 124 is a very big number, you might be thinking that it should be more than 4, or if you solved and got 4, then good job. But we have to stop here. Even though 124 is big, they just don't have that much in common. So we get 4 as our answer here, just like we did here. So the answer would be 4. Now, use any method you want to find the GCF of 36 and 15. I will be doing both methods, but personally I prefer the cake method because listing can be very time consuming. So let's start with 36. We can do 36, 1. Then let's go on to 2. You get 2 and then 18. Let's go on to 3. 3 and 12. Let's go on to 4. 4 and 9. Let's go on to 5. 5 doesn't work. Let's go on to 6. 6 times 6. So when you have like the same number, like 4 times 4, 16, or 6 times 6, 36, you only put the number 1, so it'd be just 6. Then we can stop here. Okay. Now let's go on to 15. 15 and 1. Then 2, no, 3, and 5, and me. And eventually you figure out that you stop over here. So now we can find which one is the greatest. So once you look through all of them, you'll figure out 1 and 3 are the only ones in common, and obviously 3 is the greatest. Now let's go to the cake method, which I like so much better. So the numbers are 30, 15, and 36. So this one isn't, like, cake method is sort of strange because 3 and 1 are the only numbers, so doing 1 would be useless. So you immediately have to go to 3, and then 5, and then 36 divided by 3 is 12. Then you can stop here because these numbers have no other numbers besides 1 in common. So when you just have one number, it's just this number. So it's 3. Now we can go on to 2-3, multiples. What are they? Okay, multiples are the number that another number is divisible by. So, for example, 3 is a multiple of 3 because that wasn't a very good example, but let's have 27 is a multiple of 9 because 9 goes into 27. So how can you find them? Well, suppose you're asked to find the 5th multiple or 7th multiple of something. You can find them by multiplying 9, like 9 times 7. If you're asked to find the 7th multiple of 9, you can get 63. So you can just use multiplication, or you can use the time-consuming way to list. Now let's do some practice. Pause the video and you can go over these two. Find the 5th multiple of 7, and number 2, find the 8th multiple of 32. Okay, you paused it and now you're done. Let's go on. Find the 5th multiple of 7. So I'm really not going to list it. Just 7 times 5, that is 35. Now same thing for this. Find the 8th multiple of 32. 32 times 8. So 8 times 2, 16. This is 256. Okay, we did it. Now, we can move on to 2-4, least common multiple. The list method Very time consuming, same thing. So just how here you just list everything. So for this one, it would be even harder because multiples are never ending. So ineffective. But I'll say it here just in case you prefer it. So if we have to find the least common multiple of 28 and let's see, what should I pick? 28 and 14. We can list a couple multiples of them. 28 would be 28. The next number 56. The next number 84. So that's a couple of them. Now 14, 14, 28, and we can stop here because we already see that 28 is in common. So the answer would be 28. So yeah, that's how you do the list method. Cake method. This is very effective once again. So I'll pick a different example because this one wouldn't be very like good for the cake method. But so actually, we can do this example. It's fine. So you find the greatest common factor of these numbers. So I'm gonna use this time 36 and 42. So you find the greatest common factor of these numbers. You figure, let's divide it by 2, and we find that this, so I'm going to do 2, okay, 2, and we can figure out that this is 18, and this is 21. Now, you can't do 2 anymore because this is not even, but you can do 3. So, this would be 6, and this would be 7. You stop here. But this time, instead of multiplying these two to find the greatest common factor, but when you do, the greatest common factor would be 6. To find the least common multiple, you multiply this and the last bottom numbers. So when you do this, you would get 2 times 3 equals 6 times 6 equals 36. Now, let's do it by 7. 36 times 7. So this is 42. Put the 4 here. 21. 21 plus 4. 25. So LCM, which is least common multiple of 36 and 42, is 252. All right. So as you can see, the cake method is so much better. Like if you would have such big numbers, just use the cake method, even though it's long multiplication. So much better than having to list maybe even 1,000 multiples. Now, let's go on to practice. So you can pause the video once again and do these 2 practice problems. First one, use the list method to find the LCM of 4 and 26. Number 2, use the cake method to find the LCM of 23 and 17. Okay, so hopefully you paused it and you figured both of them out. Let's try to find them using the list method for this. So let's list them down. I'm gonna do 4 first. 4, I'm gonna start from the greatest multiple greater than this, which I can figure out is 28, 28, 32, 36, 40, 44, 48, 52, 56, and 60. I'm gonna stop here. 26, 26, and then 52. Oh, you can stop. We already see one in common, 52. So the LCM of 4 and 26 will be 52 using the list method. Now, use the cake method to find the LCM of 23 and 17. So, let's do this. So, 23, 17. So, we have a problem. Nothing is divisible. So, we have a 1, because if you have nothing, you can just put a 1, 23, and 17. So, we end here. So this one was a little strange, but nothing changes. Multiply this. So when you multiply by 1, it's the same thing. So we can forget about the 1 and just multiply. 23 times 17. So 7 times 3, 21. 7 times 2, 14 plus 2, 16. No, 0 for a placeholder. 1 times 3, 3. Then we don't have this anymore. 1 times 2, 2. Now we add this. 1, 9, 3. So the LCM would be 391. So we can put LCM of 23 and 17 as 391. Alrighty. That was good. Now on to 2-5. Prime or composite. So what are these two terms? Prime means the number is not divisible by anything except 1 and itself. Okay. Oh, sorry, I typed 2, 1 and itself. So we learned what divisible meant last time. So yeah, and I think you can already guess that composite means that it is divisible by more numbers other than 1 and itself. So how can you figure out if it's prime or composite? Find the factors of the number, and if it is just 1 and itself, then it is prime. If not, it is composite. It's just like how we did the factors over here. Like we listed all of them, we found the factors. So if you don't remember, 23 and 17, as we did here, they're both prime because they're only divisible by 1 and itself. So, important note, 1 is neither prime nor composite because 1 is itself. Like, remember how we said it has to be, for it to be prime, it has to be divisible by 1 and itself, but 1 is itself and 1. So that means it's not prime, but it can't be composite because it's only divisible by 1, which is the same thing as itself. So 1 does not fit into any of these categories. So let's practice. Is the number 345 prime or composite? And number 2, is the number 89 prime or composite? So I'm just going to point out that you can also use divisibility tricks, and that will make it much quicker. So yeah, pause the video and check if you can solve these. Okay, hopefully you paused it and figured it out because we are gonna find the answer together now. Is the number 345 prime or composite? So if you don't remember the divisibility tricks, a number is divisible by 5 if it is ending in 5 or 0. So we already know that it ends in a 5. So that means it is composite. So this one, the answer is composite. Now, is the number 89 prime or composite? So when we list it, we get, all right, we're like 89. We can't use any divisibility tricks, by the way. So we get 1, 89. Then we think 2, no, 3, no. And then you keep continuing this pattern and you figure out that, wait, nothing else is divisible by 89. So we immediately know this is prime. Now we're going to go over the last topic of today, prime factorization, which is, in my opinion, the most difficult. What is it? Prime factorization is the prime numbers that multiply together to get the number, whatever number is given. How can I find it? So So like you can't really you can find it by using the factor tree, which I will show in a bit. Factor tree. Well, actually, I'll show it now before we do this practice. So, and it's only with one number, just so you're not confused. How some like LCM and GCF are two numbers. Prime factorization is with one number, unless you're comparing to prime factorization. So let's start with what's the prime factorization of 72. So the factor tree is just the factors of the numbers. So what is two factors besides 1 and 72? Because that would be useless. So the first ones that come to my head are 2 and 36. So 2, if you don't know, is prime. Once you see a prime number, just circle it, and you can stop on this side. Now 36, not prime. So I was thinking 6 and 6. That works. They're not prime, so you can't circle anything. Now 6, the only things that go into it besides 6 and 1 is 2 and 3, and they're both prime. So we already figured it out. 2 and 3. So let's circle all these. Now you can write prime factorization by just multiplying all these numbers. And if you don't know, if you actually multiply all the circle numbers, it will equal 72. So let's write them in. We usually write it going from greatest to least. I mean, least to greatest. 2 times 2 times 2 times 3, or at least that was how I was taught it. But you can write it anyway. It doesn't really matter. So 72, this is the prime factorization. Now, so let's write for here, 72 is 2 times 2 times 2 times 3 times 3. So just to double check if you want, you know that 2 times 2 is 4, and then 4 times 2 is 8. Then 8 times 3 is 24, and now we can do it here. 24 times 3 is 72. So now you can pause the video and do these practice problems. Okay, hopefully you were able to figure them out. If not, I will show you them here. So let's start with 108. 108, I know it's divisible by 9 and 12. 9 and 12. Next, 9, it's 3 and 3. So we can circle 3 and 3 because they are both prime. Well, because they're the same number, so they're obviously both prime. Now 12, we can do 6 and 2. Circle this. And this, as we've noted here, is 2 and 3. So the prime factorization would be multiplying all these numbers, which if you did notice in 72 is 2 times 2 times 2 times 3 times 3. You're just replacing one of the 2's and adding the 3. 2 times 2 times 3 times 3 times 3. So if you want to check, you know that 3 times 3 is 9, and 2 times 2 is 4, 4 times 3 is 12, and then we know that 12 times 9, like over here, is 108. So the answer for this one would have been 2 times 2 times 3 times 3 times 3. So you also need I don't know, sorry for not saying this earlier, but to do this you need a pen and a paper. Now we're going to do the last one, which is 302. So let's start with 2 because this is a fairly big number. So for 2, it would be 2, then 151. Now, if I am not mistaken, 152 is prime. So yeah, I think we can circle 151 here. So this one was a little strange, but we know that 151 times 2, or I can write it 2 times 151. So these were the answers. Number 2 was a little tricky because it's like as soon as you do it, there's only two of the things. So it's like you stop right away. It seems a little confusing, but yes, you have to stop right away. So yes, this is the end of the video. We went over factors, GCF, multiples, LCM, primary composite, prime factorization, and yeah, that was everything. I hope these skills come in handy later, and if you ever get this taught later, you already know it, so you have an advantage, and you can use these on tests if they ask you. So, thank you for watching. Bye.